All right, let's dive right into this explainer and crack open the ultimate cold case. We're talking about humanity's epic quest to unmask an invisible world that has secretly shaped our history, our health, and honestly, our very survival. For centuries, our ancestors were basically stalked by unseen killers. Today, we're going to track down the brilliant minds who finally dragged these microscopic assassins into the light.
I want you to picture the sheer terror of the ancient world. Early humans were facing these devastating sweeping plagues with absolutely zero understanding of what was actually causing them. I mean, imagine entire cities falling ill, and the best explanation anyone had was just blaming the gods. People genuinely believed these diseases were supernatural, like a divine punishment for our sins. They were searching for answers completely in the dark, fighting an enemy they couldn't even see. But, even in all that darkness, a few incredibly sharp observers started connecting the dots. Long before anyone could actually see a microbe, the whole concept of contagion, the idea that disease spreads by contact, started taking root. While most folks were busy blaming poisonous vapors called miasmas or supernatural forces, a 16th century physician named Fracastorius made this staggering leap of logic. He actually concluded that communicable diseases were caused by living agents. He called them seminaria, or seeds of disease. It was just brilliant, suspecting these invisible culprits way before we had the tools to catch them. And that brings us to the real game changer, the tool that finally blew the case wide open. Because these microbes are literally invisible to the naked eye, the entire field of microbiology was just stuck waiting for one exact piece of technology: the microscope. By combining precisely ground magnifying lenses with targeted light, scientists were finally able to peek into a universe existing right under our noses. Our whole perspective flipped in 1673. Enter Antonie van Leeuwenhoek. Now, this guy was a Dutch draper, a cloth merchant, with barely any formal education, but he had an insane amount of curiosity. He peered through a simple, homemade lens at some water, mud, and saliva, and he didn't just see dirt. He saw movement. He saw what he famously dubbed little animalcules. Leeuwenhoek wasn't just some hobbyist grinding glass in his spare time. He was effectively our very first forensic sketch artist. His single lens setup could magnify things about 200 times. That made him the first person to accurately sketch the distinct shapes of our invisible suspects. He mapped out the spherical ones called cocci, the rod-shaped bacilli, and the spiral spirochetes. He fired off these findings to the Royal Society of London, proving for sure that an entire hidden living world was right there with us. Well, as you can imagine, finding these microbes sparked a massive intellectual brawl. Where on earth were these tiny things coming from? For centuries, dating all the way back to Aristotle, the heavy favorite was a theory called spontaneous generation. Basically, this was the belief that living organisms could just magically pop into existence from non-living matter. Think maggots spontaneously crawling out of rotting meat, or microbes just appearing out of thin air in old soup. Sounds wild now, right? But it was heavily defended back then. So who finally steps up to settle this fierce debate? Louis Pasteur, a brilliant French maverick. Originally trained as a chemist, Pasteur got super interested in fermentation and microorganisms, and he was absolutely determined to prove that life, even at this microscopic scale, doesn't just spontaneously appear out of nowhere. His proof was just beautifully simple. In the 1860s, Pasteur boiled broth in these unique flasks with long, narrow, curved gooseneck tubes that were left open to the air. Now, the air could pass in and out freely, but the dust and microbes, they settled and got trapped in the curves of the glass. The result? The broth stayed completely sterile. Microbes only grew if you physically broke the neck off. With that one devastatingly logical experiment, Pasteur completely destroyed an ancient myth. He proved that life only comes from pre-existing life. But Pasteur didn't just drop the mic there. He actively built our modern defenses. His resume is staggering. He literally coined the term microbiology. He proposed the germ theory of disease, the idea that specific microbes cause specific conditions. He invented pasteurization to keep our food supply safe. And maybe most incredibly, he figured out how to use weakened pathogens to create live attenuated vaccines, protecting us against lethal threats like anthrax and rabies. All this foundational work kicks off what we now call the golden age of microbiology. From roughly 1854 to 1914, we see an absolute tidal wave of scientific discovery.
Within just a few decades, scientists tracked down and isolated the exact bacterial pathogens responsible for humanity's most feared killers, including anthrax, tuberculosis, and cholera. It was an explosive era of progress.
And the lead detective of this golden age? A German physician named Robert Koch. If Pasteur was the visionary, Koch was the meticulous, detail-oriented investigator. He built the rigorous framework we needed to definitively pin a specific disease to a specific microbe. Koch figured out how to grow bacteria on solid media and isolate pure cultures. He essentially made it possible to pull a single microscopic suspect right out of a lineup.
To actually prove a microbe was guilty, Koch used a brilliant four-step procedure that was originally proposed by his teacher, Jacob Henle. Here's the checklist. 1. Find the bug in every single case of the disease. 2. Isolate it in a pure culture. 3. Use that culture to reproduce the disease in a healthy animal. And 4. Re-isolate that exact same microbe from the newly sick animal. This became, and still largely is, the gold standard for investigating infectious diseases. Let's look at how this played out in reality. By taking the suspected pathogen from a diseased animal, growing it in a pure culture, injecting it into a perfectly healthy mouse, and then re-isolating it once that poor mouse fell ill, Koch proved, beyond a shadow of a doubt, the direct link between Bacillus anthracis and the anthrax disease. This was back in 1876, and it was monumental.
Okay, so by the late 19th century, we know these invisible assassins exist, and we actually know how to identify them. Now the whole narrative pivots from just investigating them to actively fighting back. How do we use this intel to protect ourselves, especially in highly vulnerable spots like hospitals?
Well, the very first step was literally just blocking them at the door. In the 1840s, Ignaz Semmelweis realized doctors were transmitting lethal infections to new mothers simply because they weren't washing their hands between patients. Tragically, Semmelweis faced huge, stubborn resistance from insulted doctors who couldn't believe they were the problem. But total vindication came when Joseph Lister, inspired by Pasteur's work, developed a complete system of antiseptic surgery using phenol. Lister pulled surgery out of an era of horrific infections, where doctors grimly praised what they called laudable pus, and brought us into the modern era of life-saving aseptic techniques.
But what about training our bodies to fight from the inside out? Now, the basic concept of immunity was ancient. People knew if you survived a plague, you usually wouldn't get it a second time. But in 1796, Edward Jenner, the father of immunology, weaponized it. He noticed that milkmaids who caught a mild disease called cowpox seemed totally immune to the deadly smallpox. So Jenner extracted cowpox material and injected it into an 8-year-old boy. It was the first scientific artificial immunization, and it set the stage for the eventual global eradication of smallpox.
But what if you were already infected? That burning question led to another massive breakthrough: chemotherapy. And let's define this carefully, because in microbiology, this means creating chemical compounds that can actively hunt down and destroy pathogens inside the host's body, while causing minimal toxic harm to the patient themselves. The absolute genius who pioneered this was Paul Ehrlich. He had this vision of a magic bullet, a highly targeted therapy that would seek out only the disease-causing microbes. And in 1909, he found it. Ehrlich discovered salvarsan, an arsenical compound that specifically targeted the spirochete causing syphilis. With that single discovery, Ehrlich essentially invented modern chemotherapy. And that perfectly sets the stage for a true turning point: the antibiotic era. And it's wild how much of this was driven by sheer, fortunate accidents. Gerhard Domagog discovers the antibacterial effects of Prontosil in 1935. But the most famous accident? That's Alexander Fleming noticing a stray fungus, Penicillium notatum, just absolutely destroying deadly staphylococci bacteria in his petri dish. By the 1940s, Florey and Chain proved its incredible clinical value, drastically shifting the balance of power back in humanity's favor. So we conquered the bacteria. Case closed, right? Actually, scratch that. Because as scientists used filters to trap bacteria, they noticed something terrifying. Some diseases were still slipping right through. Bacteria, it turned out, weren't our only villains. An even smaller, entirely different threat was lurking in the shadows, totally invisible to standard light microscopes. We're talking about viruses, Virology evolved much later simply because these filter-passing agents were incredibly frustrating to track. Pasteur suspected they existed when he was studying rabies. By the late 1890s, scientists proved these agents were causing tobacco mosaic and foot and mouth disease. And by 1902, Walter Reed proved yellow fever was a human virus transmitted by mosquitoes. But get this, we couldn't even see these tiny assassins until the electron microscope was finally invented in 1934. The deeper we looked into this world, the more everything connected. Microbiology eventually merged right into molecular biology. In 1944, scientists discovered that DNA was the actual hereditary material transforming these bacteria. Understanding these microbes at a purely molecular level blew the doors off entirely new fields of science, ultimately unlocking the incredible power of genetic engineering. Which brings us to the climax of this historical detective story. Look at the arsenal we've built up over the centuries. Powerful antibiotics, highly effective vaccines, cutting-edge genetic engineering. It is an absolute triumph of human ingenuity. But it really begs the question, are we finally safe? Have we permanently defeated these invisible assassins? Well, the sobering reality is that the case is never truly closed. Microbes are the ultimate biological survivors. They are constantly mutating, constantly adapting. Just look at our ongoing battles with viruses like HIV, the sudden emergence of novel diseases, and the terrifying rise of antimicrobial drug resistance. Our microscopic enemies are always finding new ways to strike. It leaves us with one critical takeaway. Unceasing vigilance is absolutely essential. Because in the world of microbiology, the real question isn't if another invisible threat will emerge, it's what that threat will be and how prepared we'll be to face it.